Let's consider this equilateral triangle here, and let's look at its symmetry group. So what are the symmetries of this triangle? First, ignore the numbers and ignore the points on it, just the triangle. So what can we do? We can rotate 120 degrees, and again, So, and we can let it sit where it is. So we have these 280-degree rotations in one direction or the opposite direction, and the identity. And then we also have the possibility to reflect. I want to consider not only rotations this time, but also reflections. So reflect across this line, which would bring us here, or reflect back. Or we could reflect across this line, which brings us here. Or reflect across, which line did we have so far? This line here. Was that what I just showed? Anyway, you see what I mean. Lines through one corner and the middle of the opposite side. Now, what about the numbers? I wrote the numbers 1, 2, 3 in the corners here. So by reading off the numbers in this order, I can take note of the configuration of the triangle. So after one rotation, it's here 3, 1, 2. Or after this reflection here, it's 3, 2, 1. And now we see that the symmetry group of this triangle is isomorphic to S3, the permutation group of three numbers, because we get all permutations of the three corners by doing the rotations and the reflections. Okay, and now orbits. Let's look at this point here, the center of the triangle, the green point. When we rotate and rotate and rotate, or reflect, this point always stays in the same place. So the length of this orbit is 1. This is a very special point here. If we look at this red point here, which I drew exactly in the middle between corners 1 and 2, this point can move over here, or down here, or back here, and also by reflections it moves over here, or when we reflect here now, it moves down here. So the orbit of this red point here has length 3. It's also a special point. This point here is a typical point, this yellow point which I circled. So here's point 1 of the orbit, the identity applied. Now we rotate, we get another point up here. Rotate once more, we get a point down here. Now we go back to, hopla, the original point. And now we can also reflect, and then it comes up here. That's a point we didn't have before. And when we rotate it again, we get additional points. So we get 1, 2, 3, 4, 5, 6 points. So that's a typical point, symmetry group of order 6, orbit of length 6.